Hello everybody. So this video we're going to extend on the last video, which was talking about the zero product property, and we're going to look at how to solve trigonometric equations using the zero product property, which really just means when we have to factor. But a basic example would be like tan squared theta minus 4 times 16 sine squared theta minus 1 equals 0. So in this problem, we have already gotten the factored form of this. And what we then need to do is just apply the zero product property. If this number times this number equals 0, that means that tan squared theta minus 4 equals 0, or 16 sine squared theta minus 1 equals 0. So if tan squared theta minus 4 equals 0, that means that tan squared theta equals 4. And then I can take the square root of both sides, and that's going to tell me that the tangent of theta equals plus or minus 2, because square root of 4 can be positive or negative. Which really means that theta is going to equal the tan inverse or arctangent of 2, and theta is going to equal tan inverse or arctangent of negative 2. And at this point, we will not calculate it because that is not a unit circle value. This would require a calculator, which I just do not happen to have sitting by me right this second. So we're going to have to leave it as this. On this side, we have 16 sine squared theta must equal 1. And then that means that sine squared theta must equal 1/16. And this tells me that the sine of theta must equal the square root of 1/16, which is plus or minus 1/4. So this has told me that the sine of theta is 1/4, or the sine of theta is negative 1/4. Which means that over here, theta equals the inverse sine, or the arc sine, of 1/4. And then theta equals the inverse sine, or arc sine, of negative 1/4. And again, we would need a calculator for this since that is not on the unit circle. We can't just instantly know the exact value. But this does give us a way of representing the solution, even though we would need to use our calculator to calculate the exact value, or to calculate a approximate value. Let's look at one that requires a little bit more work. Let's say we have 2 sine squared theta minus sine theta minus 1 equals 0. Okay, now one thing that could be helpful would be to do a little bit of side work here. And the way that I like to do that is I like to say let A equal sine theta. So I'm going to rewrite this now as 2a squared minus a minus 1 equals 0. And this is a quadratic. So we can just factor this out. Again, we look for two numbers that add to give us our middle term, our linear term. That would be negative 1. Those same two numbers need to multiply to give me 2 times negative 1, which is negative 2. And if we're quick, we should be able to gather that those would be negative 2, positive 1. And in the last video, I factored this using a box. I'm going to factor this using grouping this time. So 2a squared minus 2a plus a minus 1 equals 0. These two have 2a in common, so I'm going to write 2a, and that's going to leave me with a minus 1. These two don't have anything in common, and if they don't have anything in common, we say that they have 1 in common because that's not going to change anything, and that would be a minus 1 equals 0. Now if we look at this, we have a minus 1 here, a minus 1 here. Those are the same, so we can factor those out, and that leaves us with 2a plus 1 times a minus 1, and that's going to be what equals 0. This is the brunt force work of what we need to do. So now let's go back to our actual problem. Remember I said that a was sine theta. So that means that 2 sine theta plus 1 equals 0, or sine theta minus 1 equals 0. And if sine theta minus 1 equals 0, that means that sine theta must equal 1, which means that theta is going to equal the inverse sine, or the arc sine, of 1. And the arc sine of 1 is pi halves. And then, of course, because of the way the trig functions work, we would add plus 2 pi k, because the period is 2 pi. Now over here, 2 sine theta plus 1 equals 0 tells me that 2 sine theta equals negative 1, which tells me that sine theta equals negative 1/2. So this means that theta equals the arc sine, or inverse sine, of negative 1/2. And that means that theta equals one of two values. Theta is either going to equal 7 pi over 6, or it's going to equal 11 pi over 6. And then, of course, we'd have to do the same for both of those. So like theta equals 7 pi over 6 plus 2 pi k, where k is an integer. And theta equals 11 pi over 6 plus 2 pi k. So this is our 3 between 0 and 2 pi answers, and then the 2 pi k's is extending it to all real numbers that match this criteria. Okay, let's look at 2 more. Sine squared theta minus sine theta minus 2 is 0. And again, I'm going to say let a equal sine theta. This means that I have a squared minus a minus 2 equals 0. I'm looking for 2 numbers that add to give me that negative 1 from my linear term. 2 numbers that multiply to give me 1 times negative 2, which is really just negative 2. And that is going to give me negative 2, positive 1. And because of the fact that there is a 1 in front of my a squared, this factors out to a minus 2, a plus 1. And of course, that's going to be equals 0. So, now let's go back over to the actual problem we're trying to answer. Since we have this, that tells me that sine theta minus 2 equals 0, or sine theta plus 1 equals 0. Now, I'm going to work with the sine theta minus 2 first. So if that's true, that tells me that the sine of theta equals 2. But the range of sine is always between negative 1 and 1. Which means that I'm never going to be 2, so this has no solution for this part. Okay, over here, we now have sine theta equals negative 1, and that means that theta equals sine inverse, or arc sine, of negative 1. And that's going to occur when we're at 3 pi over 2, according to our unit circle. And to extend that out, that means that theta equals 3 pi over 2 plus 2 pi k. And we're going to look at one more, which I should be able to fit here on this page as well. And that's going to be tan theta sine theta minus sine theta equals 0. Now, whenever we are factoring, we should look for a greatest common factor. The greatest common factor of these two terms is sine theta. So I'm going to factor out a sine theta from both. So that would give me sine theta, then tan theta minus 1 is 0. And now the zero product property tells me that the sine of theta equals 0, or tangent theta minus 1 equals 0. Well, if the sine of theta equals 0, that means that theta equals sine inverse of 0. And this is going to occur at a couple of places on the unit circle, specifically 0 radians and pi radians. So, this means that theta, if we can really kind of think of it this way, one of two ways. We can either say that theta equals 0 plus 2 pi k, and theta equals pi plus 2 pi k. Or we could just say that theta equals 0 plus pi k, because that's going to include both of those. Now over here on a tangent, if tan theta minus 1 equals 0, that tells me that tan theta is 1, which means that theta is tan inverse of 1. And the tangent is 1 when theta is at pi fourths radians, according to the unit circle. Which means that in general, our theta is going to be pi fourths plus the period of tangent, which is pi k. So hopefully this video clarified some issues that people were having with trigonometric equations that involve factoring. Understand that you do not have to do things like I did here. You don't have to substitute in that a. That's what I like doing. That helps me simplify the problem down. It is by no means required. But the things that you will need to have a good grasp of are factoring, quadratics, and polynomials in general. But that will do it for this video, and I hope you have a good day.